Welcome to the channel Physicscompanion. In my last video, we have discussed a specific heat of substances where there is a change of temperature without phase change. Now let us see the change of phase without change in temperature. So what is this latent heat? Latent heat is connected with a change of state, or you can say phase change with no temperature change. That means no change in temperature. Let us try to understand. Let's say I have water at 5 degrees centigrade. Then when I supply heat, that is upon heating, let's say I am raising the water temperature to 15 degrees centigrade. So in this one there is a change in temperature is involved and no phase change. So here it is water, here it is water, and this Q can be written as mc delta T, which we have discussed in my last video. So this change in temperature is because of changes in the kinetic energy of the molecules in the water, that we will discuss in a separate chapter. Now let us see, if I have 1 gram of ice at 0 degrees centigrade. Now I am heating it. So 1 gram of water at 0 degrees centigrade. So here temperature is the same, 0 degrees centigrade, 0 degrees centigrade. So there is no change, but here it is solid ice is getting transformed into liquid. So there is a phase change. So change of state, which is inherent, hidden. So you do not see any change in temperature. So temperature is the same, so which we cannot perceive. That is why it is called latent heat, cannot perceive. Matter is classified into 3 states, as we know. What are the 3? Solid, liquid and gas. A transition from one of these states to another is called change of state. Transition. So as you can see here, solid is getting transformed into liquid. So transition from one state to another is called change of state. So to simply understand, when there is a phase change, you have latent heat, and when there is a change in temperature, you have specific heat. So that is the whole idea that we need to understand conceptually. Now the 2 common changes of states are solid to liquid and then vice versa, then liquid to gas or vice versa. So these are the common changes of state. These changes can occur when the exchange of heat, this happens when exchange of heat. Exchange of heat means you can have heating or cooling. Exchange of heat takes place between the substance and its surroundings. So ice on heating is getting, so ice on heating, that is solid, on heating gets converted into water, so that is liquid. Then vice versa is water on cooling, that means heat is extracted from water. So liquid, solid, water. So heat is extracted, so we call it as cooling. So on cooling it becomes ice. So in these cases there is no change in temperature, as we can see. There is no change in temperature of the system through heat is supplied. So T is constant. No change in temperature means T is constant. This solid to liquid, this process is called melting. Solid to liquid is called melting, the process, and this process is called freezing. So T remains constant. So the heat supplied is used in changing the state from solid to, so whatever that heat we supplied is used in changing the solid to liquid, and this is called melting. Then fusion, this I need to write fusion. Okay, so if the change of the state from water to ice, that is liquid to solid, it is called fusion. T remains constant until the entire amount changes its state, that is either ice melts or water freezes. So freezing is also can be mentioned. So freezes or water vaporizes when heat is added or removed. So both solid and liquid states of the substance coexist. So they coexist in thermal equilibrium. In thermal equilibrium. Coexist in thermal equilibrium. Both solid and liquid coexist in thermal equilibrium during the change of state from either of them. The temperature at which this solid and liquid states of the substance in thermal equilibrium with each other is called melting point. The temperature at which the solid and the liquid states of the substance in thermal equilibrium with each other is called melting point. It is the characteristic of the substance. So melting point. So the temperature at which these are in thermal equilibrium, that is thermal equilibrium, and that is what is called melting point. Melting point. It is the characteristic of the substance and also depends on the pressure. Depends on pressure. Therefore, melting point of a substance at standard atmospheric pressure is called normal melting point. Normal melting point at standard atmospheric pressure means 1 atmosphere. 1 atmosphere. Now, change of state from liquid to water vapor. So, liquid to water vapor, gas. Let us say I have water and I am heating it. So, this water is now vaporized, getting, so this process is called vaporization. This is called vaporization. The temperature at which here what are the two states which are in thermal equilibrium? Liquid and gas. Liquid and gas. Here gas means water vapor. Water vapor. So these two are in thermal equilibrium, that is coexist in thermal equilibrium, and it is called boiling point, and that particular thermal equilibrium temperature is called boiling point. Boiling point. So boiling point again is proportional to pressure, and it increases with increase of pressure, decreases with decrease of pressure. The boiling point at standard atmospheric pressure is called normal boiling point. Normal boiling point. Normal boiling point. All the substances do not pass through these three states. There are some substances which pass through solid to vapor without passing through liquid directly and vice versa, and that process is called sublimation. What is sublimation? From substances which pass from solid to gas, that is vapor, directly without liquid state. So that is sublimation. Example like solid carbon dioxide, that is called dry ice, and also iodine. These are certain examples. So here what are the two phases which coexist in thermal equilibrium? That is solid and vapor. These two coexist in thermal equilibrium. So let us now define the latent heat. There are two different latent heats. One is latent heat of fusion, then which we will denote it as LV, and latent heat of LF, vaporization, LV. So let us see first the general definition. Certain amount of heat energy is transferred between substance and its surroundings when it undergoes a change of, so the key word here we need to remember is change of state. So change of state. The amount of heat per unit mass transferred during change of state of the substance is called latent heat of the substance for the process. Latent heat of the substance for the process. What do I mean by for the process? Whether it is fusion or vaporization, without changing the temperature. Important point is without changing its temperature. That's a key. So there is a change of state without changing the temperature. So this is latent heat. The heat required during a change of state, and it is denoted with the letter L, capital L. So the latent heat of transformation and mass of the substance undergoing the change. So thus if M is the mass of a substance undergoing a phase change of state, undergoing a change of state, then the quantity of heat required Q is equal to M into L, or L is equal to Q by M. The units are, L is a latent heat, it is a characteristic of the substance, and the units are, L units are J joule for Q, that is heat, kg inverse for mass, so kg inverse. In CGS units, you will write that as calorie per grams. So L depends on pressure. If it is solid to liquid, if it is, the change of state is solid to liquid as we have discussed, it is called latent heat of fusion, LF. And if it is liquid to gas, it is called latent heat of vaporization, LV. Now, based on this understanding, let us now try to understand the heating curve of water. Heating curve of water. Now, I will consider temperature T, degrees centigrade. So, I will have 0 here, 100 here, let us say. So, I have this, let us say I have this, I have this. Now, 0 is melting point, 100 corresponds to boiling point, and our x-axis here is a heat. Okay, so here it is ice, that is solid, and so these slope lines represent the increase in change in temperature, and these horizontal lines represent phase change. So, no change in temperature, so phase change. Here also phase change. So, here it is ice and here it is liquid, that is water, and here it is gas, that is water vapor. So, as you can see, the ice is melting and it becomes water here, and so there is a phase change. So, whenever there is a phase change, as we have discussed, there is no change in temperature. No change in temperature means this temperature is on y-axis and this is horizontal, so there is no change in temperature. And here it is LF, so that is latent heat of fusion, and that is 3.33 into 10 to the power of 5 joules per kg, or 80 calories, kilocalories, 80 kilocalories per kg. And here this is latent heat of vaporization, LV, from liquid to, so there is a phase change here, liquid to gas or water vapor, and this is 540 kilocalories per kg or you can write 22.6 into 10 to the power of 5 joules per kg. So that is your standard value for latent heat of fusion and latent heat of vaporization. So the temperature changes from 0 degrees to 100 degrees. So that's when boiling point, and so then water starts becoming into water vapor. So here it is the liquid to water vapor. So that is vaporization. Here it is fusion. Is melting into liquid. So as slowly the temperature rises from 0 to 100 degrees centigrade. So that is water. So during the change of the state or phase, the temperature remains constant, as I have shown you here in these two cases. And so here Q, in these slope slanted lines, Q is mc delta T, mc delta T, mc delta T, whatever is the change in temperature. And here in these phase change values, Q is here Q is ml, and here also Q is ml, corresponding to this. So it indicates that slope lines are different, as you can see, and specific heats of various states are not equal. And LV is usually greater than LF, the latent heat of vaporization. Hence, we might have experienced burns from steam are more serious than those from boiling water, and that is because of this condition. In my next video, we will talk about Newton's law of cooling. Until then, keep watching, keep learning. Thank you.